All right, students, we are back with a brand new unit. This new unit is all about this word, vector. I'm sure this is a word you've heard before, but unless if you've taken physics, I don't know how much experience you have with this. So what exactly is a vector? What is a vector? All right, let's start with a couple definitions. So when we talk about the word scalar, a scalar quantity, this would be a measurement. Scalar quantity, this would be a measurement with magnitude only. Okay, so if I told you, for example, I was traveling 65 miles per hour, okay, or if I were to told you that I was pushing with a force of 8.5 newtons, well, these would be examples of scalar quantities because I'm giving you this value, I'm giving you like a size, or like a speed, but I'm not giving you any direction. So if I'm going 65 miles per hour, that's might be a good thing to know, but where to? In what direction am I heading? Am I going to the north or to the south or to the west? Okay, compare that to a vector quantity. A vector quantity, this is a measurement that has two things. A vector quantity, it's a measurement that has magnitude and direction. Okay, both of those things. So let me give you some example of a vector quantity. If I were to say, hey, I'm driving 70 miles per hour northeast, okay, well now you have a vector because not only do you have a magnitude, like a size of the measurement, a numerical value for the measurement, you also have an angle or a direction. We're heading to the northeast. Okay, here's another example. If I said I'm pushing with a force of 9.2 newtons, 30 degrees from horizontal. Okay, and usually, a lot of times, in the way we'll be studying it, a lot of times we'll give it with a vector. We'll give an angle measure, and it's always from horizontal. These are examples of vectors. They have the magnitude, but then they also give us a direction. Okay, so magnitude then. The magnitude of a vector, this would determine the length of your vector. Okay, the length of the vector, that's your magnitude. And a lot of times we can denote magnitude. You use like absolute value symbols. So like if I have a vector named u, if I have this vector u, and I want to talk about just its magnitude, I could put that u in absolute value symbols. That denotes its magnitude. Okay, and then the direction of a vector or a vector quantity, I just wanted to kind of put this in writing here. The direction of a vector is typically stated as degrees from horizontal, very similar to how we studied angles in standard position. Okay. Now vectors can take three main forms. That's what I want to talk about here. So the first form of a vector is just geometric form. You can draw a vector without any graph. It doesn't have to be like on a coordinate plane or a grid. It can kind of just be out in space like this. A vector, let me write down a few facts for you. Okay, when we draw a vector, it's shown as an arrow, but there's only an arrow on one side. It's similar to a ray in geometry. And you can write this vector here, if we know the endpoints, we could write this vector as OP, vector OP, kind of bolded. If we kind of put it in bold print, that's one way to write a vector. Or you can write OP with a little arrow symbol above it. That also denotes a vector. And if we wanted to talk about the magnitude of this vector, we could write something like this, the magnitude or the length of vector OP. And then O has a name. The O is known as the initial point of the vector, but it's also known as the head. O would be called the head of the vector, whereas P, the side that has the terminal point or the arrow, that is called the tail of the vector. Okay, so this is one way to draw a vector. This is just kind of out in open space, not on any grid or on any graph, just kind of out in open space. Now, let's compare that to another way to write a vector. This is called rectangular notation. Okay, with rectangular notation, let me write down a few facts here. With rectangular notation, your vector is going to be drawn on a coordinate plane, and typically it's going to be starting at the origin. Now this vector here is called v. The way we would write this is we would say this vector v is Now these are called angle brackets here that I'm using. What I would do is I would see where the vector ends. It ends at 4 on the x-axis and 2 on the y-axis. I would write this vector using angle brackets as 4, 2 in these angle brackets. And this denotes you have a vector where 4 is called the horizontal component of the vector, and 2 is called the vertical component. Okay, basically this vector travels horizontally 4 units, and it travels vertically 2 units. But put it all together, it just travels that direction in a straight line. This vector is, in rectangular notation, it would be 4, 2 in these angle brackets. This is a good time to point out as well, there is one kind of additional way you could write rectangular notation. I like to use this A, B form with the angle brackets. There's another way to write it using something called an I and a J. Okay, some people would write that exact same vector using an I with a little hat on it and a J with a little hat on it. This is another way to say 4, 2. Me personally, I prefer this way, rectangular notation. Although you will see some from time to time people will use this. It's called unit vector notation. But as for me, I'm rarely going to use this. I'm going to stick with this rectangular notation. It's just my preference. Now notice rectangular notation is always placed on a typical coordinate plane with your x-axis and your y-axis, right? The point A kind of corresponds with the x-axis. The coordinate B corresponds with the y-axis. And so when you see a vector on a coordinate plane, you're typically going to think rectangular notation. However, this brings us to the last way you can display a vector. It's called polar notation. The last way you can draw a vector, that you can graph a vector, is not on the coordinate plane that we're used to with an x-axis and a y-axis. This is actually called polar coordinates. Okay, you'll notice you still have an origin here at 0, 0, but then you have these rings that just expand out from the origin, and then you have these different angles listed. Okay, so let's say we have a vector right here. I'll call this vector u. Okay, from the origin, you can see that this vector has a length of 1, 2, 3, 4, 5, 6, 7, 8, and I can find that by counting the rings. Okay, with polar notation, we're still going to use the angle brackets like we did before. But in polar notation, the magnitude of your vector goes first. This vector has a magnitude or a length of 8 units. And then the angle is going to go second. This angle is right between 225 and 270. So we'll just estimate it looks to be right around 240 degrees. This is how we write a vector in polar coordinates or polar notation. All right, let's say, so we have another vector here. Let's call this vector over here v. So v then, kind of try this one on your own first. Try this on your own. Hit pause right now. See if you could list the coordinates of this vector v. And hopefully you've had a chance to kind of try this on your own. The magnitude of this vector is 1, 2, 3, 4, 5. I can find that by counting the rings. And then the angle is that this vector points at a 180-degree angle. So we could say vector v has polar coordinates of 5 and 180 degrees. All right, so I think your first assignment will be pretty simple, just as an introduction to vectors. This assignment is going to be a little bizarre. You're going to be using a tool called GeoGebra. So I might even post a second video just to kind of give you the ins and outs of how to use GeoGebra. But here's all of your vocabulary. Here's all of your information. Best of luck on your assignment. Take care.